Kia ora and welcome to the October Jodcast from Space Place at Carter Observatory here in Wellington, New Zealand. We're really noticing the lighter mornings and evenings now as the Earth continues its orbit around the Sun and we move closer to our Southern Hemisphere summer. By the end of October, the Sun won't set until around 8 p.m. here in Wellington. As we leave Jupiter behind on its outer orbit, it's slowly disappearing from our skies. It still sits low in the west at the beginning of the month, setting as twilight ends, but by mid-month it will be lost in the sunset. Saturn is now our best bet for evening planet viewing, sitting midway up the western sky after dark. A little below and to the left of the planet is Antares or Rehua, marking the heart of Scorpius, which we call Te Matua Maui, the fishhook of Maui, here in New Zealand. October is a good time to look out for the zodiacal light, a triangular glow visible in the west after sunset in a clear dark sky, tilting up towards Antares. The zodiacal light is caused by sunlight reflecting off dust along the plane of our solar system. This plane is marked by the ecliptic, the apparent path of the sun across the sky, which runs through the constellations of the zodiac. At this time of year, the ecliptic makes a steep angle with the horizon, making the zodiacal light easier to observe. Whilst not easily seen with the naked eye, Neptune and Uranus are also in our evening skies, with Neptune in the constellation of Aquarius and Uranus in neighbouring Pisces. Uranus reaches opposition on the 20th of the month, when it will be directly opposite the Sun in the sky and overhead at around 1 a.m, now that we're observing daylight saving. At magnitude 5.7 it is just on the edge of naked eye visibility, but with binoculars should be easy to spot. A small telescope may reveal it as a disk with a greenish hue. Just to the north of Pisces is the constellation of Pegasus, the winged horse, which appears to leap across the northern horizon in our late evening sky. Pegasus is easy to spot by the great square of stars that makes up his body. The brightest star in the constellation is the reddish star Epsilon Pegasi, marking the horse's muzzle. This star is commonly known as Enif, deriving from the Arabic word for nose. Epsilon Pegasi is an orange supergiant, around 12 times the mass of the Sun, and with a radius some 185 times larger. Nearby, to the bottom left of Enif, and visible in the same binocular field of view, is the Globular Cluster M15, one of the oldest and best-known star clusters in the sky, with an estimated age of around 12 billion years. The cluster is located around 34,000 light-years away and measures 175 light-years across. M15 is probably the most densely packed globular cluster in our galaxy, with half of its mass concentrated within 10 light-years of the centre. It has been suggested that this massive concentration of stars may be caused by a rare type of supermassive black hole in the cluster's core. With binoculars, M15 will appear as a fuzzy star, whilst a medium-sized or larger telescope will reveal individual stars, particularly towards the outer regions, appearing as chains and streams radiating out from the core. M15 also contains the planetary nebula Peace 1, the first to be found within a globular cluster. At magnitude 15.5, this is a faint object, and a telescope with an aperture of at least 300 millimeters would be needed to observe it. On the opposite side of the sky, the Southern Cross, or Te Punga, sits low in the south-southwest, its long arm pointing up across the sky to Achernar in the southeast. Achernar is at the tip of the constellation of Eridanus, the river, and is also known as Alpha Eridani. It is the brightest star in the constellation and the 9th brightest in the night sky. It is a hot blue main sequence star around 7 times the mass and over 3,000 times the luminosity of the Sun. The traditional name Achernar derives from the Arabic phrase al-Ahir al-Nar, meaning the end of the river. Although interestingly, this name was once given to Theta Eridani, now known as Achernar, which was the brightest star in the constellation visible from ancient Greece. Achernar spins on its axis extremely quickly, completing one rotation in just over 2 days. This high rotation speed gives the star a flattened shape, with the diameter of its equator over 50% greater than that of its poles. Infrared observations from the Very Large Telescope in Chile have also identified a smaller companion star with around twice the mass of the Sun. The two are extremely close, with a separation of just over 12 AU, slightly larger than the distance from the Sun to Saturn, and orbit once every 14 to 15 years, although the highly distorted shape of the primary makes these numbers hard to determine. Below Achernar, just above the south-southeast horizon, our second brightest nighttime star, Canopus, twinkles colourfully. The two make an almost equilateral triangle with the southern celestial pole, the point in the sky directly above the south pole of the Earth, about which the whole sky appears to rotate. Another easy way to find this is to put one hand on Achernar and a second hand on Gamma Crucis at the top of the Southern Cross, and clap them together in the middle. Between the southern celestial pole and Achernar, and above Canopus, you may be able to spot two small fuzzy patches of light, easily seen with the naked eye on a dark moonless night. These are the large and small Magellanic Clouds, two small irregular dwarf galaxies that neighbour our own. Whilst these galaxies are much smaller than the Milky Way, they still contain billions of stars. The Large Magellanic Cloud, or LMC, is the lower of the two and is located 160,000 light-years away. Through binoculars or a small telescope, you may be able to spot a number of young star clusters visible as small patches of light. The LMC contains one of the largest and brightest star formation regions known, called the Tarantula Nebula, or 30 Doradus. Spanning around 600 light-years across and covering 13 arc-minutes in the sky, the Tarantula Nebula contains over 800,000 stars and protostars and is the most active starburst region identified within our local group of galaxies. If it were placed at the same distance as the Orion Nebula, it would be so bright that it would cast a shadow here on Earth. The star formation activity within the Tarantula Nebula began a few tens of millions of years ago, and some of the largest and brightest stars born within this region have already reached the ends of their short lives. In February 1987, Supernova Sn 1987A was discovered in the outskirts of the Tarantula Nebula by astronomers at Las Campanas Observatory in Chile and independently by prolific amateur astronomer Albert Jones here in New Zealand. This supernova was the closest since the invention of the telescope just over 400 years ago, and provided a unique opportunity for astronomers to study such an event in unprecedented detail. Reaching a peak magnitude of around 3, SN 1987A was easily bright enough to spot with the naked eye. Smaller and more distant at around 200,000 light-years is the Small Magellanic Cloud, or SMC. The Large and Small Magellanic Clouds are gravitationally bound and have a bridge of gas between them showing evidence of tidal interaction. To the top right of the SMC, you may spot a faint fuzzy star. This object is not actually associated with the SMC, but is a beautiful globular cluster called 47 Tucanae, or NGC 104, located just a tenth of the distance away on the outskirts of our own galaxy. At around magnitude 4.1, it is the second brightest globular cluster in the sky after Omega Centauri, and can be easily seen with the naked eye. With binoculars or a small telescope, it is a wonderful sight, revealing a densely packed central core, whilst a larger telescope will start to resolve some of its millions of ancient stars. At the far end of the long winding river of Eridanus is our summer constellation of Orion the Hunter, with bright blue Rigel, the first star to rise after around 11 p.m. mid-month. Below and following around an hour and a half later is stunning red Betelgeuse, marking the Hunter's shoulder or armpit. We'll be exploring this part of the heavens in much more detail over the next few months as it moves into our evening skies. But this month we turn our attention to the constellation in the morning skies, the best time to see the Orionids meteor shower, the radiant of which lies a little below and to the right of Betelgeuse. The Orionids peaks around the 21st of October, when the Earth passes through the trail of dust and debris left behind by Comet Halley. The shower can reach rates of 25 meteors per hour, but from the latitude of New Zealand, around 10 per hour is more likely, with the radiant below the horizon until the early hours of the morning. The best time to look is in the hours before dawn. Try looking around 20 degrees away from the radiant, so the areas from Taurus around through the top of Orion to Canis Major are probably your best bet. Whilst the meteors may be few and far between, they also tend to travel quite long distances on the sky, and sometimes leave persistent trails of ionized gas behind them that can last for several seconds. With a new moon on the 20th just before the peak, leaving us with nice dark skies, you should have a good chance of Orionid spotting this year. Wishing you clear skies from the team here at Space Place at Carter Observatory.